Platonic solid.
Platonic solids. In approximately 350 BCE, or before Common Era, Plato introduced Platonic solids in his work Timaeus, which all the known forms of matter, such as earth, air, fire, water, and ether, are composed on 5 elemental solids: the cube, octahedron, tetrahedron, Icosahedron, and Dodecahedron. Pythagoras discovered the cube, tetrahedron, and dodecahedron. On the other hand, octahedron and icosahedron was discovered by Plato.
Why is there only 5 Platonic solids? In geometry, there are special groups of polyhedra, but Platonic solid is one of the most interesting cases. We're also called the 5 special polyhedra. These 5 solids are perfect or regular polyhedra. So why is there only 5 Platonic solids? The simplest reason why is there only 5 Platonic solids are these. At each vertex, at least 3 faces meet. Maybe more, but at least 3 of the faces meet. When we add up the internal angles that meet at the vertex, it must be less than 360 degrees because at 360 degrees, the shape flattens out. So hexagon has 120 degrees, internal angle multiplied by 3 faces is equal to 360 degrees, which won't work because the shape flattens out. Therefore, regular pentagon is far as we can go.
Properties of Platonic solids. These are things that we need to know about Platonic solids. First, all the faces are regular and congruent. Platonic shapes are convex polyhedrons. Faces of Platonic solid do not intersect but except their edges. The same number of faces met at each vertex. Platonic solids have polygonal faces that are similar in forms, heights, angles, and edges.
This one is a tetrahedron and it has 4 triangular faces, and from Greek meaning 4-sided 4-face, this shape is 4 equilateral triangles joined along 6 edges to form 4 vertices or corners. It makes for a sturdy pyramid. Among the Platonic solids, only the tetrahedron has no faces parallel to one another. This is a cube and it has 6 square sides, and from Greek meaning a 6-sided die, the cube is 6 squares joined along 12 edges to form 8 vertices, and it is ubiquitous to our modern society and known to humans for 1,000 of years. And also, the cubes have 3 pairs of parallel sides. This one is parallel to the back face, and the upper face is parallel to the down face, and this side face is parallel to the other side face. This one is an octahedron and it has 8 triangular faces. From the Greek, 8-face or 8-sided, the octahedron is 8 equilateral triangles joined along 12 edges to make 6 vertices or corners. The shape has 4 pairs of parallel faces.
Dodecahedron, from the Greek word dodeca, it means 12. It is called a dodecahedron because it is a polyhedron that has 12 faces, and each face has 5 edges, and these join 30 edges to form a 20 vertices. In each vertex, 3 edges meet, and this shape is the second most rounded of the Platonic solids. Icosahedron, from the Greek word icosa, it means 12 faces, and each face is an equilateral triangle. An icosahedron has 20 equilateral triangle joined along 30 edges to form
12
vertices, and each vertex 5 edges meet. Because of its relatively shallow angles, and as you can see, it most closely approximates a sphere among the Platonic solids.
the advantages and disadvantages of our chosen instructional material, Platonic solid. The advantages. First, Platonic solid is powerful with high-level command, which means that the Platonic solid is a powerful fundamental tools used by experts like engineers. Second, it is easy to construct with minimum steps. Well, making the Platonic solid requires patience, but don't you worry because it's not that difficult to construct. Just make sure your measurements are accurate. Let's proceed to the disadvantages. First, it requires a great deal of computation to derive the information on the boundary, faces, and edges, which is important for the interactive display or manipulation of solid. As what I've said, in making Platonic solid, the measurements should be accurate because if you get the measurement wrong, even one wrong measurement means you won't be able to construct it perfectly. Second disadvantages is time consuming. By constructing it, it takes us a lot of time. Why? It is because of our own experience. Story time. We construct the instructional material, the Platonic solid, in the home of one of our groupmates. So we decided to meet there, and then we expected it to take only one day to complete, but we didn't. So our leader decided to finish the undone by himself and one of our groupmates. That is why one of the disadvantages of making it is time consuming.
These are the learning materials of Platonic solids we created, a product of hard work and teamwork. Kudos to all of my groupmates. These learning materials are useful, particularly in solid geometry. If you are asking why we need to study this, simply because, apart from its natural beauty, many interesting uses of Platonic solids exist, especially in technology. For example, the Tetrahedron. It is frequently applied in electronics. In terms of geophysical modeling, Icosahedrons have proven to be useful, and if you are going to observe, most of the speakers have polyhedral faces because it is used to radiate sound in all directions. Through research, I have found two examples where all Platonics can occur. First is the Radularia. It is an organism which are protozoa, a single-celled organism that is widely distributed throughout the ocean, whose mineral skeletons are shaped like various regular solids. And the other one is the famous Rubik's Cube. I know you are familiar with it. So, fun facts, did you know that the Platonic solids are originally discovered by Pythagoreans and they were called the Pythagorean solids? And another one is that in 2003, cosmologists in France and USA using NASA radiation data confirmed that the universe is finite and is likely the shape of Dodecahedron. The idea of the Platonic solids are not just about the shape or the figures, but it is a gateway through sacred geometry, a language of the universe. These are the patterns we follow in creating the Platonic solids. And these are our outputs.
3, 2, 1.
Hello!